they get across what a complex fraction is, then they throw in the variables. These look really crazy. We want to keep in mind that this is a division, and just to save some spot, I'm just going to go ahead and invert and multiply. So the top one's going to stay the same. 15s to the 4th over 3t to the 5th u to the 3rd. But then we're going to multiply by the reciprocal of the bottom one. So the 9t squared u goes up on top, and the 5rs squared is going to go on the bottom. Again, we can do some reducing. I'm going to start with my numbers. I can divide by 5 here. So 5 goes into there 3 times and into there once. I can divide by 3 here. 3 goes into here once and into here 3 times. My variables again, I'm going to subtract the lower one from the bigger one. So if I have an s to the 4th and an s squared, I can take out the s squared. If I take 2 off of 4, that leaves me s squared up on the top there. My t's. I've got a t squared on top, t to the 5th on the bottom. Again, I can take out the lower one, so I'm going to take off the t squared. 5 minus 2 gives me t to the 3rd down on the bottom there. And then the same thing with the u's. I've got a u on top and a u to the 3rd on the bottom. I can only take off 1, so I get rid of that one. If I take 1 off of here, I get a u squared. That's all the canceling I can do. On the top, I've got a 3s squared times a 3, so 3 times 3 is 9, 9s squared. On the bottom, I don't really need the 1. I've got a t to the 3rd, a u to the 2nd, and that little r smashed in there. Since I like it alphabetically, I'm going to write the r first. Not that it matters. So r, t to the 3rd, and u squared are all left on the bottom.
So this 1, it just goes in with the t?
Yeah, you don't really need the 1 because 1t cubed is the same thing as t cubed.
Oh, okay.
Right? Or if you think about it this way, if I had 9 over 1, it's just 9. So you don't really need the 1 if the 1's left over, unless there's nothing else there. So 5's the same kind of thing. I've got that complex fraction. Means I'm dividing my 2 fractions, so I've got to invert that second fraction and multiply. So the top's going to be 7mn squared over 12x to the 3rd y. That's going to stay the same way, but then I've got to do the reciprocal of the bottom. So the 3x to the 4th y to the 4th is going to go on top, and the 28n to the 4th is going to be down on the bottom. 7 goes into there once and into there 4 times.
And 12 and
3 goes into here once and into here 4 times.
And n?
I can take out what?
2.
The n squared, so I can take out 2 of them. Leaves me 2 on the bottom.
And x?
Okay, on the x's I can do x to the 3rd out, which leaves me just a plain x on the top.
And the y.
And just one of our y's, which leaves me y to the 3rd on top.
And it will equal x, y, right?
X, y to the 3rd, right?
Yeah.
And what else is on top?
Oh, the m.
The m. That didn't disappear, it's still there. So watch for that. Just like up here, this r was left over. We didn't do any canceling with that. It's just kind of stuck in the middle. It's easy to miss. And on the bottom, we're going to have...
Oh. Wait, 16.
16
N squared.
n squared. So we get mxy cubed over 16n squared. And the m can be on the end if you put it on the end. It doesn't matter, the order. So number 6, same kind of thing. I'm going to divide my two fractions, which means I need to invert and multiply. So 21c to the third d over 5ab squared times 10b to the fourth over 7c to the fourth d cubed.
We can take out the 7 and the
7 goes in there once and into there 3 times.
and the 5 and 10.
5 goes into there once and into 10 2 times.
And then the C,
You take out
3 of them.
3 of them, which leaves me just a c on the bottom.
And the D,
And the d I can take out.
C, or D squared.
So I get a d squared down on the bottom.
And then the B, take out 2 of it.
Take 2 of those, so I get a b squared up on the top. So on the top I'm going to have
6 B squared.
6b squared, and on the bottom
1, or just C, or no, A, C, B squared.
a, c, and d squared are all left on the bottom. All right.